Find the area of the triangle formed by the lines joining the vertex of the parabola x square equals to 12y to the ends of its lattice rectum. Pause the video, give this a try. I encourage you to draw this up and see where this triangle is. Okay, so let's do this together. X square equals to 12y. This is an upward parabola. The vertex is at the origin. This is how the parabola looks like. This is the lattice rectum, and we need to find the area of this shaded triangle. How do we do that? There are multiple ways to do this. One way would be to figure out the base and height of this triangle. For that, we need to find the coordinates of some of these points. Okay, let's begin. Well, one thing that we can use is that the lattice rectum passes through the focus. So first we need to figure out what the focus is. X square equals to 12y. Let's compare this with x square equals to 4ay. This gives us 4a equals to 12 or a equals to 3. So if a is 3, the focus is at 0, 3, which means this point is 0, 3. The lattice rectum passes through this point. So this must be the focus. It's 0, 3. This gives us this length. If this is 0, 3, this is 3 units. So we have the height of this triangle. Now we need the base. How do we figure out the base? Well, that's just the length of the lattice rectum. That's 2b square by a. And if you recall, the length of the lattice rectum of a parabola is equal to 4a. That's 4 times a, which means it's going to be 4 times 3. That's 12 units. So with this, we have the base of this triangle as well. That's equal to 12 units. We have the height. We have the base. We can figure out the area. That's half base into height. So area of this triangle is half times 3 times 12. 2 cancels out. 3 times 6 is 18 squared units. So this means the area of this triangle is 18 square units. Let's try one more. An equilateral triangle is inscribed in the parabola y square equals to 4ax, where one vertex is at the vertex of the parabola. Find the length of the side of the triangle. Pause the video, try visualizing what's happening, and then try to solve it. Okay, let's break this down. An equilateral triangle is inscribed in this parabola. This means that the triangle sits inside the parabola. We're also given that one vertex is at the vertex of the parabola. So of the 3 vertices of this triangle, one of them is at the vertex of the parabola. Let's first draw the parabola. This is y square equals to 4ax. It's a standard parabola whose vertex is at the origin and it's facing right. So this is the parabola. Now one vertex of this triangle is at the vertex of this parabola. So it's right here. The other 2 are here. Now this is an equilateral triangle and we need to find the length of the side of this triangle. How do we do this? Well, just like the previous problem, we need some coordinates of some points. Let's start with the origin. This is 0, 0. Now if we get the coordinates of one of these points, we'll be able to figure out the length of these sides. How do we do that? What should we use? Well, one thing that we're given is that this is an equilateral triangle, which means all the angles are 60 degrees. We also know that a parabola is symmetric about its axis. This means if this angle is 60 degrees, this one, the one above the x-axis, is going to be 30 degrees. So is this one. Now we have the angle that this line makes with this x-axis, and we also know a point that this line passes through. Using these two, we can figure out the equation of this line, and using that equation, we can figure out the point of intersection. So let's do that. Let's find the point of intersection of the parabola and the straight line. The parabola is y square equals to 4ax. The equation of the line passing through origin, making an angle 30 degree with the x-axis, is going to be y equals to tan 30x. This is going to be the slope of this line, and this line passes through the origin. Tan 30 is 1 by root 3. So this equation is y equals to x by root 3. Now let's solve these two. Let's plug in y equals to x by root 3 in this equation. This is x square by 3 equals to 4ax. Now this is a quadratic in x. This will give us 2 values of x. One of them is going to give us this point, the vertex. The other one should give us this point. So if we cancel x out, we get x equals to 0. And if x is not 0, the other solution is x by 3 equals to 4a, which means x equals to 12a. So either x is 0 or x is 12a. When x is 0, we're sitting at the vertex. When x is equal to 12a, we're sitting at this point. Now we have the x coordinate. We can figure out the y coordinate using one of these equations. Let's use the equation of this line to figure out the y coordinate. Let's plug in x equals to 12a here. This is y equals to 12a upon root 3. Cancelling root 3, we get 4 root 3a. So this height is going to be 4 root 3a. Using symmetry, we can say that this is also 4 root 3a. Now we have the y coordinate of this point. Either we can use distance formula to find the distance between this point and this one, or we can simply observe that this side is equal to twice of 4 root 3a, which is 8 root 3a. This is going to be the length of this equilateral triangle.